Assalamualaikum warahmatullahi wabarakatuh. We will present about the application of differentiation, which is approximation. So now, let me introduce you our group member, which is Nur Izzati binti Suhaidi, Nurul Alia Syafiqah binti Muhammad Hisanuddin, Ahmad Syahin Haikal bin Abu Bakar, and Ninino Syafiqah Eliana binti Afendi. Linear approximation or linearization is a method we can use to approximate the value of a function at a particular point. The reason why we use linear approximation is because it can be difficult to find the value of a function at a particular point. For example, we know the square root 9 is 3, so we can just simply calculate it even without using the calculator. But what if the question asks for square root 9.3? The answer must be a little bit more than 3, so this is where the linear approximation can be useful. The formula for linear approximation is a function that is used to approximate the value of a function at the nearest values of a fixed value. It is based on the equation of the tangent line of a function at a fixed point. We can use the linear approximation of a function fx to find the value of fx at the nearest values of a fixed number x equal to a. The linear approximation is denoted by Lx and is found using the formula Lx equal to fa plus f prime a x minus a, where f prime a is the derivative of fx at x equal to a. If we find the equation of the tangent line at the given point, the value of the function at any point that is very close to the given point can be approximated using the equation of the tangent line. This is the concept of linear approximation, and since it is done using the tangent line, it is also known as the tangent line approximation.
For the objective of the video is to show how to calculate approximation question in application of differentiation, and the objective of the approximation is to make the approximation as close as possible to the actual function. And in this video, student will be able to learn how to calculate the differential of a function and use differential to approximate values for expression.
First of all is about the problem statement, which is under the subtopic of approximation. The question is, given fx equal to x squared plus 2x the power of 3 over 2. Use differential to approximate 4.02 squared plus 2 times 4.02 the power of 3 over 2 to 2 decimal places. Based on the problem statement, we need to approximate 4.02 square plus 2 times 4.02 the power of 3 over 2. So we have to use the formula, which is fx approximate to fx naught plus f prime x naught times delta x. Before we use that formula, we need to find the value of x, x naught and delta x. First, x, which is the given decimal numbers, is equal to 4.02. X naught is the nearest whole number, which is equal to 4, and small changes, delta x is equal to 0.02. Then, using the value above, we have to find the value of fx, fx naught, f prime x, and f prime x naught. Fx is given in the question, which is x squared plus 2x the power of 3 over 2. So, to find the value of fx naught, we need to substitute the value of x naught into the fx equation. Hence, the answer for fx naught is 32. Second, we need to find f prime x by differentiate the equation of fx. Then, we get 2x plus 3x the power of 1 over 2. Therefore, we can find the value of f prime x naught by substitute the value of x naught into the f prime x equation, and the answer is 14. After we get all of the value, the final step is we need to substitute into the formula of fx approximate to fx naught plus f prime x naught times delta x. So I can conclude here that the answer is 32.28.
As one conclusion, I could say that the objective that we use to find the value of approximation in these problems are accepted and the solution to find the value are succeed. Next, approximating has always been an important process in the experimental sciences and engineering, in part because it's impossible to make perfectly accurate measurements. Approximation also arises because some numbers can be never expressed completely in decimal notation. In these cases, approximations are used. For example, we use approximation in adding salt to food while cooking. We use approximation when we try to figure out the time it would take to reach a certain place by car. In our daily life, we use approximations in many situations. They are useful as they save time. Thank you, madam.
This is the list of reference that we use to complete this video. So that's all from us about approximation. So thank you everyone for listening.